Hello everyone, we're going to go over loops in these next few videos, and to start it off we're just going to start with a very basic explanation of them and then see the different types. So let's jump right in. If you look at the first bullet there, you'll see repetition control structure. That's its computer name, but if I tell most of my students that definition of it, they will look at me funny. But the key here is to look at that very first word, repetition. So I could say, repeat hello 3 times. And you'd say, hello, hello, hello. That's repetition, right? But what happens if we do this in programming? Well, in C#, it might be something as simple as message box show, hello, message box show, hello, message box show, hello. And you write 3 lines that look identical. If that's the case, why not try to get C# to just rewrite that same line 3 times? And in fact, it makes even more sense when you get out to like something that has to be done 100 times. And guess what? C# does this. And it does this through 2 basic types of loops. And this is pretty much true for all computer science. So let's look at those types. The first one is controlled number, and that is essentially what I just said. I told you to say hello 3 times, or I'm telling C# to say hello 3 times. 3 is a specific number, and that's how many times it has to do it, and then it's done. This is complemented by a second type of loop, which is called the controlled response. Controlled response says you can do this 3 times, you can do it 18 times, you can do it 221, you can do it 1,000,000 times. I don't know how many times you're going to do it, but you're going to do it until a condition is met. And you can kind of think of this as in terms of an assembly line. If somebody says, okay, you're going to screw this bolt in today, that's your job. And you're going to do it until all the cars come through here, or until you run out of bolts. Makes sense? Then you don't know how many cars are coming through, but you know that when you run out of bolts or you run out of cars, you're done. Same thing here in programming. We could have said, write hello until somebody pushes a button saying stop. That would be a controlled response. We don't know. We're going to loop, right? We're going to repeat over and over and over, but we don't know when it's going to stop. There has to be some other type of data or extraction in order to make this work. Now, getting back to the whole idea of repetition control structure, that just says essentially we have these specific keywords in programming that we can use to start up a repetition. This language is already put in, and it is going to control how we repeat something. That's it. So if we go into the flowchart world, this is basically what it looks like, and it should look similar to the if statement. In other words, you're going to see this diamond, the decision. But the difference between the if statement was if it was true, it'd follow one path and keep going, and if it's false, it'd follow another path and keep going. Here, what we're going to see is we're going to turn up and go upon itself. So we're going to start off with, is this true? If it is true, like say, is x greater than 5? If it's true, do this, or subtract 1 to x. And then it's going to evaluate it again. Is it still above 5? No. Okay, well then get out of that section. But as you can see, if it keeps continuing to be true, it will go around in circles until it ends. This is going to be true for both structures, both the controlled number and the controlled response. This is just going to test if the number is finished on the controlled number, and this is going to test if the criteria is passed for the controlled response. We're going to come back and look at the for loop, which is the most used controlled number type of loop.